everyone, welcome to Modern Application Development Part 2. Now I want to take a little while to talk briefly about JAM, right? You would have probably heard the term JAMstack, right? And it essentially refers to JavaScript, APIs and Markup, right? And give a few thoughts on why this is a good way in some sense of building apps, or at least a very well structured way that exists at present. Is it necessarily the best or the end of the road? Unlikely, but we'll get to that later. So the first thing to understand, right, why would we even go for any kind of these kind of stacks is what exactly does an app need? There are a few things. One is it needs a data store, some place where the data corresponding to the app is actually kept, right? So I need to be able to access the data, retrieve the data, make modifications to the data. I can have APIs for that, right? And how exactly is the data stored? That could be done using SQL, NoSQL, GraphQL. We have seen all of that. Of course, GraphQL is not a replacement for SQL or NoSQL, as we saw, right? It's more of a way of interacting with the data, right? But the point is, without the data, the app by itself is unlikely to be very useful. Okay, there has to be something that the app provides, which means that there is something that it stores and processes. Then of course there is the user interface, which is used to interact with the user, right? And the original HTML approaches was just vanilla HTML plus forms, right? Every single interaction between the client and the server was you either click on a link or submit a form. The server looks at what you sent and responds appropriately. Okay, you can build a lot of very powerful functionality just using that, right? And what has been happening over the years is you have brought JavaScript in for the primary purpose that you want to make it more interactive and closer to a native look and feel, so to say, right? It should feel more like a native application, meaning that's something that is directly running on your system, right? And not something that is going back to the server for every update on the screen. And of course, the other thing that an app needs is the business logic. What should be done with the data, right? And you have, once again, you can break this up into certain amount of backend computation, right? What kind of processing of the data should I do, which can be done in many languages, right? It could be Python, it could be Go, Node.js. All that depends on the person who's implementing the system, right? On the other hand, you have the front end computation, right, which is usually handled with JavaScript. That's sort of the dominant, clearly dominant language on the front end at this point. The only real alternative at this stage would be what's called WASM, right, WebAssembly. And the interesting thing is you actually have sort of converters from various other sources, including JavaScript, to WASM, right? So is WASM an equivalent of JavaScript? They serve slightly different purposes, right? JavaScript is easier to write and debug. WASM is more for performance, but yeah, they both run on the front end. So with all of this, the one interesting thing sort of moving forward from the regular apps that we have been looking at, where everything is designed from scratch, is to say that, look, can we sort of think of a different kind of approach? And there we see that there are these things called content management systems, right? And if you are working with, let's say, an example of a blog where you want to create a blog, right? You would have the standard CRUD approach for creating posts and comments. You might have ratings that you want to associate with posts and comments. You need to have some kind of user management, certain analytics. But you look closely at this and you realize that, the content management systems that we are used to are always something web-based. They have a front end, they have a specific way, they have themes and so on. But all this functionality is actually data manipulation, right? And it can be done independent of the user interface, right? One of the oldest and most popular of such content management systems is what's called WordPress, right? You very likely have heard the term, you might even have used it at some point, right? It handles both the data storage as well as the front end. In fact, if you look at it, WordPress is implemented in PHP. PHP is primarily meant for creating the front end, right? It turns out it can also have the logic corresponding to the back end in it. But the interesting thing about WordPress, and you can look at this document on their own website, it provides an API, and this is part of the evolution of WordPress, right? Essentially what it's saying is they have recognized the fact that people might have reasons for trying to use the data present in their CMS without necessarily wanting the same front-end interface, right? So an API, in other words, can be used to build a CMS without a front-end, which means that you can now provide your own front-end. You can create your own front-end using Vue or any other kind of technique that interfaces with this API. Okay, so WordPress is not the only one, of course. There are in fact nowadays a large number of different such systems that are effectively saying, look, we are not even going to look at the front end, right? But they still call themselves content management systems, and effectively what they say is they are what are called headless content management systems. Okay, so a headless content management system is something that just takes care of the data storage aspects, provides some kind of basic interface for managing the data storage, but the actual display and how you go about constructing the blog page or whatever the application that you want is left up to the end user. Okay, and this is in some sense a powerful abstraction, right? There are people who are good at managing the backend side. Let them focus on constructing the CMS in a headless manner, and somebody else can then take care of specializing the front end. There are a number of such things that can be used with APIs like this, right? You might already have come across a number of so-called static site generators, right? There is Next.js, there is Nuxt.js, which is like Next but with Vue instead of React, right? There is Gatsby. Most of these are JavaScript based, and essentially what they are trying to do is that they are saying that you can build an app, actually, not just a website. Okay, why? Because Next.js, for example, works with React. It allows you to not only have content, right, but also have JavaScript associated with it, which means that you could create something with a Next.js front end that then interfaces with, let's say, a WordPress API at the back end, but now provides you with all the functionality you want to create your own unique kind of blog application. Okay. On the other hand, there are static site generators that are primarily text oriented. They just generate pages, okay, not necessarily interactive, right? Jekyll and Hugo are examples. There are of course many others. I think the last time I checked, there was in fact a web page called staticsitegenerators.net or something like that, which had more than 300 such examples, right? So pretty much anyone can create their own static site generator, but these are the more popular ones these days. And what's the idea behind it, right? Once again, we are sort of going full circle. We started with plain HTML, went to introducing JavaScript, went overboard with JavaScript where everything had to have JavaScript and everything was dynamic, and then people slowly came back and said, look, that's making things too complicated and overloading your clients and your servers too much. Let's simplify and have the main page as just HTML and use the JavaScript for additional interactivity and functionality as needed. Okay, so it's sort of all these developments happen in cycles, right? And so once again, we are at this point where the static sites are the ones that really make sense in terms of handling large loads in an efficient manner. So the servers can focus on delivering content, and there is this term that is used which is called first contentful paint, right? These are things that we will be looking at in a little bit more detail when we look at measures of performance. Okay, and the idea behind first contentful paint is that when I go to a website, how quickly does it actually display something on the screen, and how do I know when there is something on the page for me to read, right? And if I'm transferring pure HTML, the chances are that I will be able to sort of very easily transfer it, parse it, and display it without any complications. Okay, it can be displayed very quickly. So static files generally tend to be faster to fetch, and I can do lots of compile time optimizations to reduce even what is being transferred. Even if there is JavaScript, I can strip it out and specify only some parts of it to be sent. Okay, so static site generators, in other words, are a good way of approaching the construction of large sites. Are they necessarily the best way of constructing an app? That depends on how you go about it. You could sort of use the static site generator to construct all the text and the documentation of the site. The actual core application would certainly need something like JavaScript. And there is an interesting sort of take on that, which is called hydration, right? It's just terminology, but it's an interesting way that of looking at it, which is to say that you first just send static HTML, right, from the server. There is no interactivity, but something gets displayed on the screen very fast, and then subsequently transfer the JavaScript that actually hydrates the page, meaning that there is some bootstrap JavaScript or some core JavaScript that is already there in the page, whose job is to pull in the other modules, take its own time over it, but then make the page interactive, right? And all of this is a question of how you can sort of more efficiently build up a user experience that is closer to what would happen if everything was running on your own local machine, and give you a better user interactivity and performance. Yeah. All of this ultimately is what you find when you look at what's called the JAMstack, right? The JavaScript, APIs and markup, which is what we were looking at all along, right? The JavaScript part we have looked at in a lot of detail, right? And Vue is what we sort of saw as a good front end. APIs, there is REST, there is GraphQL, there are different ways by which you can retrieve data. And markup, there is of course the standard HTML markup, or you could use Markdown and similar text-based markup languages. But all of them put together take care of all your problems, right? There is storage, logic and presentation, right? So the storage is the API, the logic is the JavaScript, and the presentation is the markup, right? All of these together are taking care of any app, in other words, that requires these three components to be present can be built up using this some variant of the JAMstack, right? And the thing to keep in mind is the JAMstack is not a single unique set of components. It is just anything that uses this approach, right? And is this sufficient? Is that all you can ever really expect or require from an application that's going to be running on your system? The short answer is no, for two things. One is of course what we have not looked at so far, but which can be handled to some extent, is things like real-time communication, okay? Actual chat or even video or audio conversations, right? Other kinds of things where you actually need to be able to directly interact with a remote system, okay? There are ways by which it can be handled in JavaScript, right? There is in fact something called WebRTCs, a WebRTC. There are WebSockets for directly pushing information from the server to the client and so on, right? So there are a few more things which can be handled even with the existing JavaScript. But what that is sort of telling you is that not everything is going to be a storage plus logic plus presentation type of app. And more importantly, what happens as we come up with new interfaces, right? Holographic displays or some kind of haptic display, haptic interfaces where there is also a touch interface associated with how you use it, right? The vibrate mode on the phone is just a most basic form of a haptic interface. There can be much more advanced versions of this, right? Three-dimensional displays, things that are immersive, right? Virtual reality, all of those. Are these kind of techniques sufficient to take care of all of that, right? Is of course the question that we have, right? And the point is that the JAM approach at present is general enough that it can be extended in most cases through the use of APIs for interfacing. But why did JAM even come into existence? Because people felt that this whole idea of going back and forth between the server and the client was too slow and did not give a good user experience. Which means that even though in principle JAMstack is capable of handling all of these different functionalities, this will only be as good as it works until you are hit by performance issues. At which point it is entirely possible that people will come up with the next big thing, right? What is the next evolution going to be? We don't know. It's hard to predict at the moment. There might be things that sort of try to build up on the existing technologies, or something fundamentally that disrupts what we have. At the moment though, this is a very good sort of set of technologies that are available for building web applications.